All right, 5.2, proving trig identities, day one. The biggest thing that I can emphasize when it is the proving trig identities is that we need to show our work. Here are your steps. You're going to start with one side. I would pick the more complicated side as we're doing this, and use your algebra one step at a time. You are only going to change one side. That is very important. The other side will stay exactly as is. Your goal is to make whichever side you decide to pick to work with match the other side. And as soon as it does, you're done. You can only do one step at a time. So make sure you are showing, it's kind of like a geometry proof. We don't get to skip steps as we are doing this. Show all of your work as you are doing that, one algebraic or trig identity step at a time. So let's go ahead and jump into this. Something like this, cosine secant over tangent equals cotangent. And again, we're going to work with the more complex side to try to make it match. So what I'm going to do is I'm going to work with our cosecant, sine secant tangent. And we're going to make it match the side that says cotangent x, and we do not change this. Do not change that side, so it is going to just remain a cotangent x, and once the left-hand side also says cotangent x, we would be done. So one of the things we could do is look at the fact that the numerator is an identity, so I could rewrite that secant as cosine of x. And what you might want to do, and on this one you'll notice, is I don't end up changing the denominator. I would only do one step at a time, and as you only do one step at a time on this one, you're actually going to see that it will speed up the process for us. Cosine over 1 times 1 over cosine, your cosines will cancel, will leave us just a 1. And because I didn't change the denominator, I can actually already see the identity for cotangent. 1 over tangent equals cotangent x, and as soon as it matches this side, which it does, we would be done. We have proved that cosine secant over tangent equals cotangent. All right, so on the next one, again, picking our more complex side, the left-hand side has a cosine, a tangent, a sine, and a cotangent. The right-hand side only has a sine and a cosine. So I would pick, again, on this one, the left-hand side to manipulate. And again, I'm trying to move towards something with a sine and a cosine. Maybe that's where we start this one, is just converting everything to sines and cosines. So let's go ahead and do that. I'm going to work with the left-hand side. So I'm going to rewrite tangent of x as sine over cosine. Rewrite cotangent of x as cosine over sine. And I can already see as I look at that our multiplication, which is what would happen first, my sine of x and sine of x in the numerator and denominator would cancel. So my first step was to simplify that last term into just a cosine of x. My next step is going to be to distribute this cosine of x. So I've got a cosine of x times our first term and a cosine of x times our second term. And in the first term, my cosines are going to cancel, leaving me with sine of x. And in the second one, cosine of x times cosine of x is cosine squared. And always keeping an eye on what you're trying to match, because actually we would stop here. It matches our right-hand side. We would be done. All right. Next one, we've got a tangent x plus cotangent x equals secant x, cosecant x. So let's have a quick conversation about which side is more complex. On the left hand, neither side has sines or cosines. So sometimes the sines and cosines can be our indication of the less complex side. It's usually easier to move towards sines and cosines. However, neither side is sine and cosine. The left-hand side has an addition symbol, the right-hand side does not. And I will tell you it's probably easier to put things together, meaning get a common denominator and add to be one fraction, than it is to pull things apart. You can pull things apart. We'll look at an example eventually to do that. But I would, again, pick on this one to work with the left-hand side. So if we work with the left-hand side, everything kind of runs through sines and cosines. So what I might do is turn this into sines and cosines and work our way through that, and then eventually back into like secant and cosecant. So I'm going to rewrite tangent and cotangent as sines and cosines. So tangent I would write as sine of x over cosine of x. Cotangent I would write as cosine of x over sine of x. Get a common denominator. So our common denominator is going to be all of every denominator, cosine x, sine of x. So our first fraction would be missing that sine of x. So I'd multiply top and bottom by sine of x. Sine times sine is sine squared. Our second fraction would be missing the cosine of x, so I'd multiply top and bottom by cosine of x. Cosine times cosine is cosine squared. And I can put this together to get one fraction. So we'd have sine squared x plus cosine squared x over cosine x sine x. And then I can replace the numerator, which is the sine squared plus cosine squared, with its Pythagorean identity, which is 1. And then we can look at breaking that fraction, 1 over cosine x and 1 over sine x, and replacing each of those with their identities. 1 over cosine x is secant. 1 over sine is cosecant. And again, always keeping an eye on what we're trying to match, and that is exactly where we were headed. All right, on our next one, a little bit more hard to figure out which side is more complex. So as I look at this one, the left-hand side, cosine squared and sine squared with a subtraction. The right-hand side, there is a subtraction also, but only a sine squared. So making my decision between those two, it's going to be easier to condense things and to go down to just having a sine than it is to introduce a trig function that's not currently in the function already. So I would pick to work with the left-hand side on this one. Now, I see that we've got squareds and pluses and minuses, which again gives me my indication we should be thinking in the back of our mind our Pythagorean identity, and I'll just remind you our Pythagorean identity here is going to be sine squared plus cosine squared equals 1, and all forms of that. I'm trying to get rid of this cosine squared so that I just have a term with sines in it. So if I look at this Pythagorean identity, if I were to solve that for cosine squared to see what that equals, I would see that cosine squared of x equals 1 minus sine squared x. And so what I can do is I can replace cosine squared with its identity, 1 minus sine squared. And we still have the rest of that, which would be minus sine squared of x. And so I've, again, replaced this cosine squared with its identity, 1 minus sine squared. Well, then we can put together our like terms. Sine squared and sine squared would be like an x squared and an x squared. I've got minus sine squared and minus sine squared, which would be 2 of them. So 1 minus 2 sine squared x. And actually, we would stop. We already matched the other side. All right, so again, a conversation about what's going to be more complex here. I, again, elect to work with things that are separated with pluses and minuses to get them to be one fraction than I would to pull apart a fraction. So on this one, I would start working with the right-hand side. I'm going to run through sines and cosines again. So I'm going to change the secant y into 1 over cosine. And I'm trying to put these together to be one fraction. So I'm going to get a common denominator. Our common denominator is going to be cosine. So I would multiply that second fraction by a cosine y, top and bottom. And cosine times cosine is cosine squared. And so now I can add those together, keeping them over my common denominator. And I can replace the numerator with our Pythagorean identity, 1 minus cosine squared is sine squared. And this is where a little bit of manipulation is going to happen. First of all, sine squared can be written as sine times sine. And sine over cosine is tangent. And the other part is if we've got a sine of y in the numerator, if I were to move it to the denominator, it would be its identity, which is cosecant. And the only reason I chose to do that is because that's what we're trying to match. Remember, always trying to match the other side, not necessarily simplify the way we would have learned in 5.1, but to match the other side. And so that's why I chose to move that down to the bottom of the fraction, making it its identity. All right, your assignment is 5.2, and during this time, we are only going to do problems 1, 3, 4, 5, and 6.